So, hey guys, my name is Pathikrit Bhowmick. I'm here to talk about betterfiles. It's a Scala library that I wrote. I was frustrated by doing I/O in Scala. I'm going to talk a little bit about the library, but more about like the philosophical underpinnings of doing I/O in Scala, the decision choices that I had, and the state of I/O. So, when I mean I/O, I specifically talking about file system I/O. So these are things like reading a string from a file, moving files around, doing like file system operations like chmod, chown, zipping, unzipping, deleting stuff. So I don't really mean network I/O or database I/O, just pure file system I/O. And unfortunately, all of these things are quite hard to do in Scala or Java. I know shell commands on the top of my head, which I can do most of the things with, but if you ask me to write Scala code which will do these things correctly, I cannot write them, which is surprising and unfortunate because most of the time I'm a more productive programmer when I write Scala than when I write shell, but except when it comes to I/O. So what do? I just Google and how to read a string from a file, and that's what the state of art is, unfortunately. Yeah, okay. So even if you land up on Stack Overflow, like there are these questions, read a file in Scala, write a file in Scala, and you can see the number of people who like upvoted this question. It's like the 2 top questions in Scala. And this screenshot was taken like a year ago, and it's more, the number is way more now. And even then, the top answers are incorrect in both the ones for different reasons. Well, this guy mentions like, hey, I can read a file in Python, Ruby, and some other language, Go or something in one line. How do I do it in Scala? The answer, it's out of the screenshot, is actually slightly incorrect because it leaves a file handler open. And the top accepted answer over here, it doesn't work in Scala 2.11. The library was never released for that. And the last commit was like 3-4 years ago, whatever this library is just recommending. So even if you copy paste from Stack Overflow, it doesn't always work. OK, so let's look at the state of. So I want to append some string to a file in Scala. And OK, this code looks normal. I mean, if you're like a systems programmer, this might make sense to you. You need to open an output stream. You pass that stream into a writer. You append the text, and then you have to close all the things that you opened. And this is OK. Java code, not too bad. But the problem is this is a lot of code to do a very simple thing, which is to just append a text to a file. And which is OK, fine. That's 6 lines of code. I'll write it once and never look at it. But a lot of the things are not obvious from this piece of code. Like, what happens if the file does not exist? What happens if you're trying to write to a directory? What if you don't have write permissions? What if there's a write lock on it? What if the file is a symlink? Are you going to follow the symlink, or are you going to try to write to that inode in particular? And all of this is completely not obvious from this code or even from the JDK file write utils. Well, that was fine and all. I was showing Java 6 code. That was before Java NIO came out in Java 7. So let's look at some Java 7, Java NIO things. So in Java 7, they introduced the NIO package. So java.io.file is old. Use the java.nio.file.files utils or path utils. That's the recommended way of doing things. And you want to copy from a source into a destination. And this is what you do. I mean, this is kind of fastidious. You wouldn't even write this wrapper util. You can just use files.copy. And you'll be asking, why am I talking about I/O? This is great. Like if NIO solves all your problems. But guess what? If you actually read the documentation of this thing, it says that this thing only works for files or directories that do not have any other files in it. And that's completely surprising. And you wouldn't even find it in the Java doc. You have to go to this copy.html Oracle docs, and you'll find it. Or if you're running it, you will get a java.nio.file.directory not empty exception when you try to copy a directory which has files in it. OK, so let's try to copy directories correctly. So Oracle, in all their wisdom, actually published the correct way to copy directories in this link, in this copy.java and IO examples package, which is not available to the JDK. And this is how you do it. I was a little bit surprised to see this because I thought, oh, copy would be, I'd list recursively and just do a BFS or DFS and copy like that. But you want to use the file.walk file tree util, the files.walk file tree. The reason being the operating system can give you better access to directories which has billions and millions of files. You don't want to list that and load it into memory. But anyway, this is the most idiomatic Scala code or Scala translation of copy.java to copy directories correctly. And there's absolutely no way you could have come up with this. And again, it doesn't solve the problems I mentioned. It doesn't tell you all these things. What if the destination doesn't exist? Symlink handling. How if you're copying between different file systems, does it actually work? It doesn't. OK. So before we jump into the Scala solutions, let's look at the state of the art in the Java world. So first, there's these two great libraries, Apache Commons IO and Google Guava. And they work great. I have nothing against them. They're used in production in many big companies, including Google, so you can safely use them. There are two things being Java libraries. It leaves a little bit of bad taste in my mouth. One is you always have to do something util.something and pass in files. In Scala, I would have done implicit decorations and put them on the file class. OK, fine. That's just aesthetics. Another thing is Scala has a much more powerful type system, and you can use type classes to do a lot of things. For example, the Java has a little util called scanner, which lets you slurp inputs like strings and so on. And they're defined like 10 or 15 different next int, next boolean, next blast, so on and so forth. In Scala, I would have assumed there would be type classes where you'd pass in some kind of readable type class. And it's extensible. You have one method you need to remember. That's it. But these are minor inconveniences. Or you can use plain Java and IO. But as we saw, that's really dangerous. Like even this is, again, copied from Stack Overflow. Someone asked, how do I count number of lines in a file? This code is buggy. It leaves a file handler open. And it's not obvious at all. And even the verbosity of just using plain Java and IO is ridiculous. Like if you want to chown the file, like change the owner of a file, you have to do this ridiculous thing, like files.setOwner. You pass in the file, and you get the file system, get the user principal lookup service, and lookup principal by name, and pass the owner in, and that's how you chown a file. And there's no way you could have found that unless you know like the Java docs by heart. So let's look at Scala solutions. The first is scala.io.source. It doesn't do most of the things that you want to do. It can read and write files, but if you want to zip, unzip, change ownership, delete directories, so on and so forth, you can't do any of those. So it's not that useful. Then there's Scala IO. This is an interesting thing. I want to talk about it. So, well, besides the fact the last commit was in 2012, 4 years ago, 5 years ago, and even that was updating the README or something, it was the wrong approach, in my opinion. It tried to do too much. It tried to create Scala counterparts of buffered readers and print writers and output stream readers and so on and so forth. So now you have two problems. You have to not only keep track of the Java mental model, you have to know what the Scala counterparts are, or how to go between those two, or which one to use when. So it was needlessly complex. There's Ammonite Ops by Lee Howey. He's at the conference. This is an awesome library. This was originally written for the Ammonite shell, and that's where it's used. It's great. Feel free to use it. I have some minor gripes with it. One is it has this syntax. This is how you remove a directory or a file. This is not Scala code that we're usually used to writing. That's because this was was originally part of Ammonite shell, where you can write Scala as shell commands, and that's where this DSL is very useful. And another thing is if you want to actually do something complex, like if you want to write to a file but use a different codec, or if you want to traverse a directory but you want to do different link options, so like not follow the symlink, for example. Those were not possible in it doesn't take on those arguments, at least last when I looked this summer. Or you can roll your own. And if you actually Google ioutil.scala, you will find so many results. And I think the Scala compiler has one, the Play has one inside, SBT has one inside, Akka has one inside. And they pretty much do the same thing all over again. And we as developers highly respect DRIDE, like do not repeat yourself. And I think a more important takeaway is to not repeat other people. And then there's betterfiles, which I'm going to talk about. My gripe with this is a pretty terrible name for a library. It's a historical reason it's called betterfiles, because I started adding implicits to the Java file, and I called that implicit class betterfile.scala, and that's how the name stuck. So before I talk too much about the design of Scala, the I/O in Scala, I want to talk about the philosophy and the different philosophies that exist. So Scala as a platform, as a language, attracts a lot of different ideas and a lot of different views of doing things, which is great. As someone said, Scala is a melting pot of ideas. And so there's also combinatorial explosion involved. If you take any two different weird features and you put them together, they don't go well together in Scala, but that's fine. So to give you an overview, there's some special things about I/O. I/O is inherently slow. I/O is inherently error-prone, like files cannot exist, you may not have permissions, so on and so forth. And to tackle these problems, there are very different schools of thought. There is the reactive streams, Scala philosophy, where I/O should be just streams, and you should pipe things around, move things in source, that kind of philosophy. Then there's also Scala.js is becoming popular, and there's the Node.js callback philosophy, where you pass in callbacks, which has an error handler and a success handler. Also, as Scala as a first-class language of the JVM, we have to deal with the Java baggage. And the Java baggage is all the input stream writers, buffered readers, print writers. Even now, I don't know on the top of my head which one to use when. And you have to deal with that many times when you write code in Scala. And there are also the functional school of thought, where I/O should be monadic, and there should not be side effects. Errors should be in the type system, and I/O should be done using I/O monads. That's the purely functional school of thought. And the new ideas are coming in, like the Dotty. There was talk by Martin about effects, encoding effects into the type system, and how that can be implemented in Dotty, which is the future of Scala in some respect. And that again brings a new way of thinking about I/O. As effects. And at the end of the day, as many of you are in the room, we're just engineers. We want to build something, and you just want to write one line of code. And if it's stupid and blocking and it works, you don't care. If you want unblocking, you can wrap it in a future and move on. And you can see all these different schools of thought collide and manifest in this particular Scala slip. So this was opened by someone to gather ideas about doing a better I/O library in Scala, and everyone had a completely different opinion about the best way to go about, and nothing really happened in the end. So this is my very highly opinionated implementation of I/O in Scala. So before I started to just crank out code, I made some points of what I think should be design goals I should aspire to. One is, you shouldn't need to include any other library to do I/O in Scala. So I looked at the superset of all the utils or file utils available in Guava, Apache Commons, Jod, it's a cute Java library, and the Java and I/O path and file utils. And betterfiles is a superset of all of those. No external dependencies. This is just an aesthetic issue. I didn't want to depend on any library, just depend on Java. I didn't want to do anything clever. I just wanted to wrap an I/O and remove surprises, remove inconsistencies from the API, give a idiomatic Scala, expose an idiomatic Scala interface. There's another thing that I wanted to do. I didn't want to introduce a new mental model. There's just one file class, and every new capabilities are added to the file class using implicits. And so there's no 20 different I/O classes you have to remember. This is an obvious one. API should be obvious. If you're copying things, it should not work only for empty directories. Scala gives you a very powerful type system. There are some things you can prevent at compile time. If you're trying to list a file, that should be an error. You can only list directories. On the converse, if you're trying to write to a file, but it's a directory, you should not be able to do that. And we can leverage the Scala type system to do all those things if you want. Another thing is automatic resource management. In Java, you always have to do try, finally, close. I tried to make the library use auto-closing iterators as much as possible, which basically means if the has next is false, it closes the resource underneath. And give you capabilities so that you don't have to always try close. It's a pain even with the Java 7 try with resource syntax. Again, I wanted full configurability, like, for example, the codec thing. You can pass in your own codec, but you can pass in your own link options. You can pass in your own open options, which is you want to open the file in read mode, write mode, read-write mode. But you don't have to specify 7 or 8 parameters to do something simple. All of them have default parameters, which are sane. OK, tests, good docs, performance. I didn't want to incur any performance penalty. This is as fast as Java. There's a little asterisk there because it's actually faster than Java in some places, specifically scanner. So the Java scanner uses regexes, which are extremely slow. This one uses parser combinators, which is much faster than regexes. This is, again, an external article by Lee Howey about principle of least power. I think this is by far the most important design goal of this library or anywhere you should strive to achieve. So this is a clickable link. You can Google it or read about it. The idea being is that you want to do something with the least possible abstraction or the least powerful abstraction available to you. So the core of this library is not reactive, not monadic, not effects-based, not pure, no buzzwords that you hear in the Scala conference. It's very simple wrapper and I/O. And the reason being it's not that those things are bad. You just want to use the least powerful abstraction to do something. And you can build higher level abstractions once you have a solid ground. So there are libraries built on top of betterfiles, for example, Akka File Watcher, which uses actors for watching files instead of threads. But you need a really solid API underneath for you to build that. And there's like a shapeless-based scanner, which lets you scan H-lists instead of tuples. And those are, again, built on top of betterfiles. So I'll give a quick tour of betterfiles. This was a motivation for me to update the GitHub docs, so I can present it in a conference. So, OK, let me. Can you guys see? So this is what betterfiles looks like. There's many ways of instantiating a file. You can use string interpolation. There's some nice DSL involving the forward slash. You can use a classic constructor over here. And one caveat is the file class in betterfiles is also called file. So if you don't like that, you can do import renoming to call it Scala file and call the Java one the file. I usually go the other way. I call the Java one JFile and keep the one that I like. So again, the API is that simple. This is how you do write, appends, get a string. It's just one line of code.
That example with the append line, does that open and close the file twice, or do you?
I'll come back to that.
Okay.
Yeah. There are these some coders in Scala like symbols, so there's also symbolic ones available. This one appends, this one, the single less than overrides and the double left arrow appends it, same as the Unix shell cat commands. And there's a fluent interface, so you can chain all of them. They return the file object. There are also Slurp APIs, which don't completely read everything into memory. They return iterators. These are self-closing iterators. So if you manage to iterate over it completely, it will, when the has next is false, it will close the underlying stream for you. But for if some reason you crashed out in the middle or you took the first 50 elements and just left it at that, it will not close the stream for you. So there's another alternative for that. I'll come back to that later. And yeah, most of these APIs, so as you can see, you can just, if you want to read the content, you can just do this. But all of this API still takes in about 3 or 4 default parameters. So codec is one, link option is one, another one. And you can specify, you can pass those in. But by default, you don't have to pass any customizations to these methods. And these are bridges to the Java I/O classes. So like you can convert between any pairs of like how do I convert an input stream into a buffered reader, or like how do I convert a file into an output writer. All those things are fairly easy. Your IDE can auto-suggest it, or you can just guess. They follow a pretty decent convention. Again, most of these takes 3 or 4 parameters, and all of them are defaulted. And you can convert between any pair of Java I/O classes fairly easily. I add implicits to all the Java classes, so you can just call output stream.buffered, and you'd get this one, instead of creating new buffered output stream and passing the output stream in. This is kind of alluding to the fact how you can use pattern matching and the Scala type system to do things. So you can pattern match and on the 3 most common types of files, which is a symbolic link. The extractor is the destination. Or a directory, the extractor is a lazy iterator of the children in the file. Or a regular file, again, the extractor is contents of the file. There could be other types of files which are neither directories, regular files, or symbolic links. For example, on Unix, you have process files or pipes. Everything's a file in Unix. So those things are not captured in the time system just because they're so rare. You can also use, Scala has this, you can use the extractor syntax on the left-hand side to do this. I don't know how many of you are familiar with this. So this would give you all the documents in this directory, because Scala has unapply on the LHS. Other nice utils for like globbing. This actually uses the operating system primitives instead of just listing recursively and doing a match. And all the little utils, touch, clear, rename, move, copy, link, symbolic link, all the hash, MD5, chon, chmod, some pipe operators, querying the file for locks, creating new temporary files, they're all available. And if you actually import the commands package, you will get a DSL, which is very reminiscent of the command line. You can do cp, rm, mcdir, chon, all that. It just calls the regular file API. Some more methods. I'll skip past this. Like you can get the extension, content type, modified time, hidden, or so on and so forth. Put the POSIX attributes. So this is another example where you can pass in some specific link option if you want to query it if it's a directory, which means do you want to see if the file is a directory or the symbolic link pointing to the destination is a directory or not. Chmod, there's various types of file comparison. If the path is same, if the content is same, the path is same, just looks at the name of the path, and the content actually does I/O to figure out if the content is same. There's various files ordering provided for you, like by name, by size, by depth, by modification type. Again, zip, you don't have to Google how to zip a file in Java or something. It comes with betterfiles. It uses Java I/O. This is the part where you can use resource management. So all the Java classes that are closable have an auto-closed implicit method defined on them. So you get a little monad here. I would say, since I don't depend on cats or Scala Z, this is actually just a traversable, but you can pretend it's a monad, and you can get the resource, do something, and this would close the resource for you. And this for each syntax is just cute. You can obviously write a map or a flat map. Like you can do this. That also works. And we have utilities to convert any iterators to an auto-closed iterator. And this is the Scala scanner. So if you're familiar with the java.util.scanner, it's a very useful class, but it's really slow. It uses regexes. And this scanner is extensible. You can just define a scannable type class, and it will scan for you. And it's much faster. It uses parser combinators underneath. So this is an example where I say, how do I scan an animal? You just define an implicit type class for animal saying it's a scannable because given a scanner, this is how I scan it. And boom, you can do scanner.nextAnimal. And you can't do that in Java. And same way, you can define an HList scanner. So this is a good example where building higher level abstractions becomes simple once you have a solid core. So this is literally what the shapeless scanner looks like. it's 2 lines of code. Anything, whenever you work with HList, you just have to define 2 things. How do I scan the base class HNil? Well, you can always do that. And how do I scan something which has a head and a tail, which is another HList? And it returns scannable of the H::T. And as long as both the head and the tails are scannable, and you can define it. Now you can scan HLists instead of tuples. And this is an example where we do that. We're scanning the CSV, and you get an HList back. So file monitoring is another interesting. File monitoring is another thing. The Java, I can do a whole another talk on how terrible the Java file monitor is. It has so many bugs. It cannot watch single files. It cannot recursively watch directories. It cannot, if a new directory is created in a directory, it does not automatically start watching that. It has a lot of inconsistencies. This one wraps those inconsistencies around and gives you a nice little interface. So if you want to create a file monitor, you just create a thread-backed file monitor, and you override 3 methods: on create, on modify, and on delete. And that's it. That's pretty much it, 3 lines of code. And there's a Akka-based one, which is, again, based on top of the thread-based one, where you can remove and add actors on the fly. And that's a powerful abstraction built on top of the simple file monitor. So that was the kind of the flavor of the API of betterfiles. So I didn't want, you are in a Scala conference, so I want you to take back something from this talk, not just like me advertising betterfiles to you. So these are some things that I learned that would be useful for you when designing a general purpose library. So Fluent APIs, I talked about it, are APIs where you return the object back. And so this is what it looks like. So if you have an append, it returns the file back, so you can chain the commands. But the problem here is like, OK, for append, it's obvious you need to return the file back. But when you're copying something, it's not obvious. Should you return this file back, or should you return the destination? And that's not obvious from the signature. You have to document it, or you have to read the code. So you can use Scala's literal types to encode that into the compiler and document it at the same time for free. So for append, you say, like, OK, when I append, I get the self.type back. But when I move a file to a destination, the return type is not self.type, it's destination.type. And as a programmer, this is really useful, because you know when you're doing Fluent API calls, when I called move to here, I don't have this original file back. I have this new file back when I want to work on things. Another takeaway is, since I didn't want to depend on any external library, traversables are poor man's monads. They have a for each in there, which you can use to do things. So here I define a structural type called closable. So anything is closable as long as they have a close method on it. Even though Java added auto-closable interface, but not to everything. So I rely on the structural type. And I say something as a managed resource on A, as long as A is at least closable, as just a traversable. And that's because I want to use the for each feature, which takes in a function, and I apply it, and I finally close the resource. And this adds an auto-closed method to anything that's closable, which is the structural type. So now you can use this. You can get the input stream .autoclose. This is added implicitly. You can get an output stream autoclose. You use the pipe, and that's it. This will close both the input stream and the output stream when this for each block executes. And as you may know, the for each block is just a syntactic sugar for a flat map. So future work, this is alluding to your question. In a Fluent API, each of them are opening their own file handlers. Maybe there's a way, like kind of like a database session or a transaction, where they could reuse the file handlers and push them forward. So currently it doesn't. It's an interesting work that I'm exploring. It's definitely possible, but challenging. Other things are the distinguishing between files and paths. Because sometimes you want to do I/O and sometimes you don't. Like a good example would be like to check if a file has an extension. Well, if you call it on a directory, you don't want to return that, say that the file has an extension even if it has a dot in it. But to know if a file is a directory or not, you have to do I/O. But maybe you don't want to do I/O because you're running some MapReduce on another cluster, and that file actually does not exist there. So the library, betterfiles currently does not distinguish too much between what is a file and what's I/O, and what is a path versus files, things that exist versus things that don't exist on the file system and wouldn't be doing I/O. Now that this is a great idea from Ammonite to type the paths, there's a lot of bugs can happen when you try to go from a relative to an absolute path in Java. In Java, all of them are stringly typed, so you can screw yourself up in many different ways. And there's a PR out for the Scala 2.12 release. I'm looking through it. It's going to be merged and released shortly. I'll talk about this later, about how this library can integrate into the Scala platform. So for future discussion, I'm running out of time. So this is it. That's the GitHub link. There's an active Gitter challenge. Scala docs are online. It's only 500 lines of code, so feel free to jump into the code base, look at it. There's 5 times as many lines of tests versus lines of code. Pull requests are welcome. So that's it. One last thing, recruiting. I work at a hedge fund called Coatue Capital. We do algorithmic trading, quantitative modeling. If you don't know anything about finance, that's great, because none of us know anything about finance. We're engineers, we're data scientists, we're machine learning, we're NLP specialists. So we work a lot on Scala, Spark. These are our tech stack. If you're interested, one good thing about working in a hedge fund is you can immediately get feedback from your algorithms. Like if you work in a regular company, no matter how smart algorithms you implement, you're going to get the same paycheck. Here, if you make millions of dollars on a trade, you will see a 6, 7-figure bonus on your paycheck because this is our money we trade. So even if you're not interested, feel free to refer me anyone who might be interested. So that's the email address. We have a $25K bonus for referrals. All right. Thank you. Have any questions?
So it looks like that the slip you mentioned, slip 19,
Yeah.
had a lot of activity on it. Is that just moving slowly, or is that going to?
It's just activity of people discussing things, nothing really. So the question was slip 19, there's a lot of activity, what came out of it? A lot of activity as in a lot of people chimed in what they thought was the best way of doing things, but there was no conclusion as far as I know. Any more questions?
So you have the iterable being used for scanning like a file, for instance. Did you consider like traversable ones, and why not?
That's a good question, yeah. I think traversable ones would encode the fact that you can only go through it once much more. It's in the documentation, but that's a very good point. It should be traversable ones. Thank you.
Okay.
All right.
Question. So if our file is actually a directory, so it's not iterable, it's not like by itself, not traversable once, I have to call something, right?
Yeah. Yeah. One more.
So just to clarify, if you open a file and you don't explicitly mark it as auto close, the file handler will stay open.
If you traverse, it's only for reading and writing. If you use the write method or the read, and for writing, yes, it will close it for you. For reading, as long as you slurp the full input in, it will close it for you. But if you crashed halfway through the input, it won't. But there, you can use the .auto closed version, which will close it for you, even if you crash out. All right. Okay. Oh, one more? No. Okay. All right. That was it. Thank you.